I am starting recording. Okay, where it is? Bam. So if you want to write me something, it's better to write me to Telegram, because then I open it on my telephone, I mean my smartphone, and I can read it. Otherwise it will be not so useful for me. So today we have our second lab. It will be, first of all, I understood during our first class that you had some problems with Gaussian elimination, because you didn't get, at least some of you, that it's an algorithm. It's not just what to do, but it's exactly step-by-step solution. And I try to do it again on my laptop, and I hope you will get it. After this we are going to factorization, or sometimes it's called decomposition, because in Russian it's AGLA2 decomposiция, разложение, so in English it's factorization, or also decomposition, so it's up to you. Again, disclaimer about our classes. So we have 2 online classes. It will be today or next week, in this time probably. So I am giving you a lecture-like class, so mainly I will speak and you will just watch it. And afterwards you can ask me some question, or during the... I made that you can speak, so you can activate your microphone and ask something, it's okay. And I put some tasks which you have to do at home. So I will show something, but other stuff you have to do it by at home. So first of all, we are going to Gaussian elimination. What the main goal of Gaussian elimination? First of all, we have Gaussian elimination and Gauss-Jordan elimination. The difference was explained before, but roughly speaking, it's about that in Gaussian elimination we are trying to receive upper triangle. So we have 2, 1, 1, 4, minus 6, 0, minus 2, 7, 2. And our goal to obtain such matrix that we will have some values and there is a 0. It's Gauss elimination. If we are talking about Gauss-Jordan elimination, we should, it's, let me say, its next step, we want to have a diagonal form, so identity matrix. Also we can call it like Gauss elimination is a method for algorithm for ref, reduced echelon form, and Gauss-Jordan is for RRF. Now we are going to the algorithm. So far so good? At least I'd like to understand that. Can you hear me?
We can.
Yes.
Okay, nice. So now we are going to the, to Gauss algorithm. Also I will write some special metrics, and afterwards we will get, what is it? So I will write it on the bottom of my screen. So first of all we need to take a pivot. In our case it should be first non-zero point. It's just definition which was given by string. So it should be non-zero. If it's not, current position will be 0. We can exchange our rows. So we can make it, and after this we will have not this factorization but other factorization. It's out of scope for today, for now. So we are taking 2. What our goal? We want to make that the lower part should be equal to 0. How can we do this? We just need to multiply on such value our pivot that this value should be equal to 0. So in first case, so our bottom matrix it should have 1 1 1, and we are writing, so we want to eliminate 4. So in this case we need to multiply on 2. We are writing 2 in the bottom because we just writing this number which we are using. And what will be 2 by 2 0, So minus 6 minus 2 will be minus 8, and 0 minus 2, my bad, minus 2. Okay, next step, we want to eliminate minus 2, this coefficient. For this purpose we need to multiply on minus 1. We're writing 0, so 7 minus minus 1, 8, 2 minus 1, 2 minus minus 1, 3. Okay, we finished with the first row, first column. Now we are going to the second column. First non-zero, so we are talking about second row, and our pivot will be minus 8. It's non-zero, so it's applicable. Now we want to reduce this one. For this purpose we are multiplying minus 1. So what we will get? 0, 0, 3 minus minus 2, 5. Hooray! We obtained our upper triangular form. Let's check with answer. It seems I didn't make any mistake. So it's just algorithm. I didn't think. I just, okay, I need to receive 0, what I should do? Bam bam. If you have any problems with calculation, in this case, you can do next hint. Let me say like this. For instance, I want to multiply on 2, so let's go to this guy. You can just rewrite somewhere, or you have a drafting paper or something like this, and you're writing 1, 1, 1, 4 minus 6, 0. You can rewrite multiply on 2, 4, 2, 2, 4 minus 6, 0, and after this just do this. 2 minus 8 minus 2. And after this write down it there. And after this you can clean up it or whatever. Because sometimes you can, actually more than half of this semester, you have to calculate a lot of, you have to use Gaussian elimination a lot. So it's my hint when I was young and innocent. I mean when I was a bachelor. Don't try to handle everything in your mind. Okay. So it will be your practical task at home. Of course, you can solve equations using Gaussian elimination. Actually, not Gaussian, but Gauss-Jordan. In spite of it, you just need to. Well, you should do the same stuff. You are working with left part, and also you need to do everything the same with the right part. As Gilbert mentioned during his lecture, that MATLAB, for instance, it firstly works with left part, after this work with right part inside the MATLAB code. I haven't checked it yet, but I hope he's right. So, and also I will provide you answer. Now we are going to AGLA factorization. This, so what can we see there? When we make a Gaussian elimination, we received U coefficient, is there. And our L, upper triangle stuff, is just our coefficients, which we, when we multiply something, we wrote down these coefficients, and that's it. It works only when we didn't make any, how to say, we didn't swap. Yeah, thanks. Swap our rows. That's it. If you do this, in this case, you have to use permutation matrix. Again, it's not our case right now. It's the easiest way. So you're just making Gaussian elimination, and you're making this. The case study why do we need AGLA will be further. Don't worry. Now I just recapping you what does it mean. Also we have a bit, let's say, advanced mode. It's called LGV or LDU. The difference between the previous one, that our U matrix or V in some cases, now it's upper triangular with ones on main diagonal. That's it. For this purpose we need to make a diagonal matrix in the middle and change coefficients. It's actually I don't know where it can be applicable right now, but I just have to say about this. That's it. Now we are going to the application. Actually, when we're talking about factorization, there are a lot of factorizations and we will cover them later. One of the goals of factorization to, let me say, unwrap our matrix and understand what's going on there. For instance, when we make Gaussian elimination, like LU, in this case, you can know what type of operations did you make on the left side, I mean, to make it upper triangular. And also it helps us understand the rank of this matrix. When we are looking on U matrix, we understand what's going on. But the main application is in solving linear equations. And I read datasheet from MATLAB, for instance, and for linsolve, you can Google it by yourself. Linsolve is a method, it's a function in MATLAB which helps you to solve linear equations. So you roll system of linear equations like we did it before, like this one, and it can solve this. And MATLAB use AGLA2 factorization for this purpose. So what's the goal? We have ax equal to b. After this, we can rewrite it as LU equal to x equal to b. We just, how to say, expand our a. We factor this. After this, firstly we say like LUX equal to b. Now we make that, okay, let's recall it like this. Can we do this? Yeah. And find c. In this case we will find c, and the final step is ux equal to c how it appeared, because we have, let's say, we need to change it and we will receive the equation. Because we found c in this case and we just solve this equation. That's it. So according to this lecture notes from Gilbert Strang, he called it like that: we have factor and solve steps. Now you can think, okay, now we have to solve system of linear equation twicely. Why it's more helpful? For this purpose, I recommend you to do it at home and try to solve such task. So I wrote there how you should do. So first of all, you just need to use Gaussian elimination and solve for g equal to 1 and equal to 2. So you will, in the end, you will have b1, b2, b3. Second step, you need to do the same using AGLA2 factorization, and you need to compare your time consumption. I don't want to put in your mind like capital O on N and so on, because it's not intuitively, it's for me, because I'm not a very true programmer who think in terms of algorithms like this. But as for me, it's a good practice for you to, first of all, again, train Gauss elimination, and second one, to understand where it's useful. As you may see, I wrote such task that you have dependencies. So your previous value depends on the future. So when you find x value, ax, it will depend on your next system of equations. And I also put there the answer. I'd like to highlight that AGLA2 decompositions can be different. I mean, they are not unique. As you may see, the middle part, where we have nice numbers like 1, 2, minus 3, I did it by myself, manually. And also I found AGLA2 decomposition using MATLAB, and it received some awkward numbers. In spite of it, it's correct numbers. I checked it. and the answer for B2, B3. It's the main application, at least as I found, for LU factorization. Kola, do you have any questions about this? Or somebody else? Because as I know, some of you asked me about case studies.
I think I'll try to solve that. Seems okay so far.
Good. So let's continue. Actually, continue is just I give you 3 tasks. First task, which number C leads to 0, and the answer for this. Second task is this one, and also the answer. And the last one, I solved all of them by myself, and I don't think that you will have any problems. As for me, the main goal for you is just to sit and play with it. It's the reason why I said that we won't spend a lot of time during this class, because it's quite small topic and you just need to play with it by yourself. So now, if you don't have any questions, you can just, because we have class, you can sit and try to solve by yourself, and after this you can write me to ask some questions. Because I put this reference materials, it's from book, and this lecture, and that's it. So
is the presentation on Moodle already?
Not yet, because probably you will find some mistakes during my. I'd like to say that I am doing this in LaTeX, so it's in Git. And if you find some mistakes, probably you can, let's say, fix it by yourself, if you want.
Oh, cool. Where?
If you really need it, you can ask me, and I can send you a repo link.
Okay. Well, now where do we find the tasks?
So right now, so do you have any questions regard to previous classes or something like this? Because if no, I can just send it right now and you can start to solve.
I have a question about permutation matrices.
Yeah, what's the problem?
Will there be any task related with this topic?
Did you get the goal of, let's say, what the goal of permutation matrix, why it appeared?
In case we rotate our rows, we need
rotate.
to check it.
I am going to my palm tree. Not rotate, but
yeah,
exchange
the rotate, I think he implied that it's a continuous swap that moves each row one or several steps upward or downward.
Yeah, and so actually it's appeared because the goal is that we cannot say, when we swap rows, we cannot say that we have the same metrics. We have different metrics actually. Yes, it will have probably most of the, how to say,
properties.
Yes, most of the properties. But we have to, like, when we multiply on -1, for instance, we want to, when we have some system of linear equations, we multiply on some value, like multiply on 2 or something like this. We multiply left side and right side, because we want to, how to say, have the same result. The same story there. When you swapped rotate these rows, you have to return in the same position. So you swap it, and after this you just, when you multiply permutated matrix on this A, you will return to initial condition. That's it. It's the goal.
Okay.
So the problem is that how to write this permutation matrix. Again, it's a good case for you for playing with it. So you just need to, for instance, you need to swap. Or for instance, I am writing on the whiteboard. Okay, I need. So for instance, you decide to swap these two guys. Okay, in this case, you need to understand what matrix should be there afterwards. So first of all, you need to understand that most of the time it's just 0 and 1s, like this. It's not correct, I didn't swap it, but I mean that you need just to understand how the permutation matrix looks like, and that's it.
Okay, it's clear.
Oh, fine. Anybody else?
I have also a question.
Yeah.
Why the multiplication of pivots gives us the determinant?
Does it?
Are you sure?
On the lectures of MIT and Holdov said that if we will get all pivots and multiply it by all of them, we will get the determinant of this matrix.
Only given a triangular matrix.
Yeah.
It makes sense if you look at it.
Yes, because
Like,
in this case, yeah. You can say, Col.
Yeah, in the original, I'm afraid just that he'll see my face instead of your presentation, because unless you're pinned, we see the speaker. In any case, like the original way, the original way, like by the definition, to find the determinant is to multiply main diagonal, then next diagonal, and one more number. I don't know how to explain it exactly on hands. Well, because there are zeros everywhere, every term that you have to sum up when calculating the determinant will be multiplied by 0.
Yes.
So the only term without zeros is the main diagonal. So for a triangular matrix, you only, like the determinant is only determined by the main diagonal.
Yeah, makes sense.
It's easier to draw.
No, I got the idea.
So again, you want to say that we made factors Gauss elimination, and afterwards we need to take the main diagonal and multiply them.
Yeah, firstly we have to make a triangular when we have zeros downside the main diagonal. And now when we want to calculate the determinant, all diagonals except the main will be zeros, and that's why this multiplication gives us a determinant.
Because if we are doing as you said, as I probably get what you want to say, we just make triangular matrix, you see the determinant, blah blah, you can see my slide, okay. So after this we have pivot 2, minus 8 and 5. Probably 5 won't be pivot. It should be pivot. No, it won't be pivot.
Yes, it will.
Yes, in this case, 2 or minus 8 and 5 multiplying 5 will be minus 80.
Yeah.
So it won't be a minus 60.
I'm afraid I can't see what you're typing in there.
You cannot see the...
It's too small. Doesn't change the font.
Safeguard.
Sorry.
Windows Plus, it's something like...
it's not working there. You may see bam 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 bam. Because it's the best application ever.
Oh, it's better.
Okay. So determinant will be minus
so
16.
No, I think he's talking about a triangular matrix. You're trying to calculate the determinant of some other matrix.
Why? We didn't change our matrix. Okay, let's check. Okay.
So it's correct.
So yes, in triangular matrix, yes. So to sum up, when we have so the question was, when we have a triangular matrix, why can we take the coefficients on main diagonal? It will be our determinant. So the answer is because when you write down this, you will try to solve this main diagonal, you will see that everything else will be, how to say, disappear. Okay, because for instance, when we take this one, we should take 2, multiply on minus 8 on 5. Minus 2 on 0 and will be 0. That's it. It's just because of magic from math. Okay. Any other questions? So 5.
When will be the presentation slides?
It will be in 5 minutes after the end of this session.
Okay, thank you.
Wait, will you not wait for us for our questions here?
Because we have 7 minutes. I mean, actually, because I have class right now.
Not with us, you mean?
Yeah, because I have 4 class every day except Sunday.
Are you teaching or?
No, I am a slave. I mean, I am a student. Okay, actually you read my chat in on the next class I will explain you how the education in Sirius looks like if you want.
Cool.
Yeah.
Because they have only master classes and probably you will want to recommend it or not recommend it. It's up to you. So I just catch 2 robotics students out of 7 and they explain me how it look like.
2 out of 7? You mean there are 7 people on the robotics course?
The master degree appeared only on this semester. I mean, starting from fall. So they have only 60 students.
That there were...
No, they didn't have any degree. So it's the first year of the master. Now they have the first batch.
You said they only have masters, and you said that masters only appeared this academic year.
Yes.
So before this academic year, they had no classes?
Yes.
No courses?
Yes.
So that, all right.
It's completely new university.
I see. Okay.
Okay. So.
That was not obvious.
Okay. See you guys.